Hey guys! One of the biggest problems with resin 3D printing is temperature. Most resins have an ideal printing temperature, and this is typically between 24 and 30 degrees Celsius. If the temperature falls below this, the resin can become viscous, resulting in reduced print quality and even print fails. Even Angus at Maker's Muse in sunny Australia fell foul of this issue. As he noted, even there, temperatures drop below ideal during the evenings, resulting in print failures. So, in a nutshell, if the temperature of our resin is correct, we can expect better printing results. But temperatures vary daily, and as winter is coming, I've been looking for a way to resolve this issue. Buying a suitable enclosure here in the UK has proved tricky. But luckily my buddy Richard over at Printcast Build steered me towards a perfect solution on Thingiverse. This is an enclosure heater researched and put together by X3M Snake from Photonsters. So everything you see today is the brainchild of this creator, and all due credit goes to him. Even though this was shared freely on Thingiverse, a lot of effort went into this, and I urge you all to please tip this creator. For what he's done here, he really deserves it. If you follow the link to the creator's Facebook page, you can see there's a small shopping list, and I'll repeat this in the description for non-Facebook folk. But in essence, this is what you'll need to purchase. Firstly, there's the W1209WK temperature controller, and this is the brains of this excellent device. The next thing is this 100 watts 12 volt heater. Now there's all manner of heaters out there, but don't go off script. Everything has been designed around this specific shopping list, as you'll soon see. Next, the creator recommends these very small but very powerful magnets. Finally, we need a power supply, and it's very important to choose a 12 volt 120 watt transformer with a main supply suited to your part of the world. Now, I tally all this up at roughly £46, which isn't bad for something that's going to let me print perfectly even with speciality resins and even on the coldest of winter days. The creator has gone to the trouble of supporting the body of this enclosure heater for us to print, and ironically, when I printed mine, it was a cold autumn day in my workshop. So I only just got away with it, and the print is a tiny bit warped in places due to support failure. It quickly becomes obvious that the heater doesn't fit inside the printed body, and that's because some disassembly is required. These 4 screws need to be removed and set aside, as the inner heater is exposed. Feed the wires through the opening and push the heater gently into place. Replace the spacer. Now feed the fan wires through in the same manner. Use the 4 screws to attach the fan to the printed body, securing everything firmly into place. The printed body is surprisingly strong, but don't over tighten anything or you risk breaking it. At this point, I decided to glue the magnets in place using a strong 2-part epoxy adhesive. By doing this now, I wanted to give the adhesive plenty of drying time. The thing that might put folks off doing this is the electronics, but trust me, this is very easy. It is very fiddly as it's a small space, so I can't actually show myself doing it, but here's what's involved. The temperature controller has just 4 screw terminals, plus, minus, S1 and S2. Starting with a power adapter, the chances are you'll have one of these jack plugs on it, but we, of course, need wires. Mine came with this screw terminal adapter, and if yours doesn't, There's loads of them on Amazon, eBay or whatever. Just screw in a couple of wires, making careful note of the positive and negative terminals. If you're a dab hand with a soldering iron, you might prefer to use a jack socket instead, and that's my personal preference, but the choice is yours. All the positive wires go into the plus terminal. The negative from the heater goes to the S2 terminal. This should leave you with two black wires, and these need to go into both the negative and the S1 terminal. This sounds weird, but it's fine. These two terminals are bridged. To make life easier, I used a fork connector. Now, if my wires aren't the same colour as yours, don't worry. I trimmed mine down and used insulation tape in places. Lastly, there's the temperature sensor, and this simply plugs in here. With much fiddling and swearing, you'll squeeze all the wires into the printed body and the temperature controller simply pushes in. At this point, you should be able to see what I mean by my slightly warped print. With the power supply connected, you should be greeted with something like this. Now you just need to program the controller, and the instructions aren't the clearest in the world. So let me run through the processes and critical options. Firstly, temperature scale. To switch between Celsius or Fahrenheit, just click the bottom temperature button. Now we need to calibrate the temperature, and for this you'll need an ordinary thermometer. Here you can see my sensor is suggesting the temperature is 30 degrees Celsius or thereabouts, and that doesn't happen often in the UK. It's actually more like 22 degrees, which is a difference of -8 degrees. So to calibrate this, we need to access the program function P4. Hold the set button for 5 seconds until it beeps, then release. P0 should display. Click the set button repeatedly until P4 is displayed. Now press both the set and temperature buttons together briefly. The blue display should now flash. Press either the set or temperature button to add or subtract from the current temperature. In my case, I want -8. Once you're there, do nothing for 5 seconds, and this should exit the program menu. The temperature display should now be more realistic. Next, we want to limit the maximum temperature, which is program P2. Again, for convenience, hold the set button for 5 seconds until it beeps, and then release. Click the set button repeatedly until P2 is displayed. Press both the set and temperature buttons together briefly, and the blue display should now flash. Press either the set or temperature buttons to add or subtract from the default setting. 110 degrees is a bit steep for a safety cutoff temperature. I think 40 is more realistic. Again, do nothing for 5 seconds and this should exit the program menu. My next suggestion is return difference, which is P1. The factory default is 2 degrees, but I reduced mine to just 1 degree. So when the ambient temperature falls below 1 degree of my goal temperature, the heater will be activated. Finally, and most importantly, is P0, the heating and cooling mode. By default, the controller is set to cooling, but we need it to heat. So enter the program menu in the usual way, select P0 and alter the setting from C to H. Our enclosure heater is now ready to use. You just need to enter the goal temperature. Now personally, I'm going with 26 degrees Celsius, which seems pretty middle of the road for resins. To select this, there's no need for the program menu. Instead, just click Set once. Then press either the Set or Temperature buttons to add or subtract until you reach your goal temperature. Then do nothing for 5 seconds. The finished heating unit is surprisingly compact and should easily fit inside most resin printers. But I'd recommend printing the body for a test fit, just in case. Personally, I aim for the upper left side, keeping clear of the Z-rail. The temperature sensor can dangle freely, as long as it doesn't get trapped in the workings or in the resin tray. This unit was designed for an original Anycubic photon, and these have a metal carcass, so the magnets will stick perfectly. Unfortunately, magnets don't stick to plastic. So personally, I took a small piece of steel, cut it down, and glued it with epoxy adhesive for strength. This allows me to mount and dismount the heater with ease. The only thing to watch out for is the power cable. Depending on your printer, you could choose to drill a hole or maybe file a small notch. Don't pinch the cable, as that might damage it. And don't leave too big a gap, or you may let in stray UV light, etc. Quite what gluing bits of steel and filing small holes will do to your warranty, I can't really say. So I guess that's something you'll need to think about. But the real question is, does this heater work? Well, in an enclosed space, yes, it works great. Personally, I shake my resin well, pour it in the tray, close everything and let the heater do its job for half an hour. By then, in such a small space, everything is of a similar temperature and I'm ready to get printing. The heater should click on occasionally if the ambient temperature drops, but effectively what you now have is resin printing at an ideal temperature, improving print quality and reducing failures, a real win-win. Once again, if you download these files from Thingiverse, then please tip the original designer. This is an excellent tool, competently designed and constructed. Even a small tip is better than no tip, and we really should help out those creators that share their hard work with us in this way. So I hope you enjoyed this one, guys. Take care and thanks for watching.